valve bodies, manifolds, gear housings, regulators, pump components, fuel systems parts, motor bases, prototypes of all kinds. These are just a fraction of a vast array of parts being produced on this astounding, numerically controlled machining center. It has long been the dream of the metalworking industry to mill, drill, bore, ream, and tap in one setup automatically on a single machine. To fill this vital gap in our technology, Kearney and Trecker Research developed the world's first automatic multi-machining center, the Milwaukee-Matic. Since its introduction, the Kearney and Trecker Milwaukee-Matic method has created an entirely new concept in production strategy. The major effort of our continued intensive research into the field of automatic machining has been directed toward developing maximum versatility into this unit. And that's the reason we're with you now, to demonstrate the increased capability of this new version of the Milwaukee-Matic. New features on this machine now make the benefits of tape-controlled automatic machining a practical reality in many new areas in the metalworking industry. Milwaukee-Matic is now equipped with solid-state numerical controls, proven in the field to be the easiest and most trouble-free methods of controlling machine functions by tape. The control brain is transistorized, a major breakthrough for trouble-free operation. Because these components store tape information in advance of actual machining operations, there's no waiting time for tape reading. Modular construction provides rapid accessibility for routine maintenance. A unique card tester checks out modules in a matter of seconds. This fault finder device instantly analyzes over 40 circuits and pinpoints possible trouble. A continuous red light indicates all conditions are normal. Plug-in type relays allow fast replacement. And test tapes are available to pre-check the machine control. It's significant to note that this solid-state control permits the machining of complex part configurations without the use of a computer. For example, contouring, so important in prototype work and hundreds of other applications, is now routine. This new Milwaukee-Matic, of course, has the standard features that have been proven in the field since 1958. 961 different tool codes can be recognized by the machine to mill, drill, bore, ream, and tap just about any part configuration made of just about any type of metal. There's plenty of spindle power to hog out rough cuts. However, the same spindle can also handle finishing cuts. When a tape command for a tool change is read by the tape reader, the new tool is in position in less than 8 seconds, ready, in this case, to perform a contour milling operation on the same workpiece. This boss is being machined by the contouring action of the horizontal and vertical slides of the machine. All contouring operations consisting of arcs and slopes and any 2 of 3 axes can be programmed without the assistance of a computer. The command on the tape now calls for indexing the workpiece 90 degrees to be in position to contour a large arc. The machine is capable of milling radii up to 100 inches. The tape now directs the machine to index the workpiece 270 degrees. Milwaukee-Matic is available with standard with 8 positions and optional with 360,000 positions. Perhaps you're wondering what is involved in actually preparing a part for production on Milwaukee-Matic. The pre-production requirements are fast, economical, and simple. Blueprint information is converted to a numerical control manuscript. The programmer prepares the entire operation, selecting machine positions and tooling data, including feeds and speeds. Manuscript information is then transcribed on a flexor writer to control tape. This 1-inch wide, 8-channel tape has a binary coded decimal format. At the same time the tape is being punched, all tools for the job can be preset and coded. This Kearney and Trecker precision tool setting device uses an optical system to locate the established length and diameter. While Milwaukee-Matic itself is completing one part, an entirely different workpiece can be readied on Polycheck, a machine simulator. This is an important step in reducing non-productive machine hours, tooling costs, and lead time. At the opening of this film, we highlighted just a few of the vast array of parts being manufactured on hundreds of Milwaukee-Matics all over the country. The reason for this widespread application is the machine's ability to perform a variety of operations. For instance, all types of drilling can be performed, including deep hole drilling. Precision boring operations can be accomplished without special setups. Imagine what this would require with conventional methods. Because of the positioning accuracy of the machine, no expensive jigs are required for reaming operations. And tapping of any size is just another standard operation commanded by the tape. Here's further proof of maximum machine utilization, right on the job. Parts of different sizes and shapes can be intermixed and processed with no loss of profitable production time. While Milwaukee-Matic continues to manufacture one part, the operator places an entirely different job on the shuttle without pause or interruption of the machining process. Preset tools for the changeover can be inserted into the magazine while the machine is running. They can be placed in any position due to a patented coding system. A tape for the new part is inserted in the reader, and the job is ready to go. When the part on the machine is completed, a tape command automatically unclamps the pallet and simultaneously shuttles the finished part off and moves the new part onto the index table. When the new part is in position, the machine control unit switches to the new tape and begins to respond to the new programming. Milwaukee-Matic is the only machine tool that fully utilizes the profit potential of numerical control. What you have just seen has upset the old established theory of economic lot size production. Make 1, make 10, make 100. The machining cost for each part remains the same. Up to this point, we've talked primarily about the hardware concept of Milwaukee-Matic. Now let's consider for just a moment the management fringe benefits this method offers. For example, floor space. One machine does the job of many. When your company is faced with the need to expand, the saving of floor space can contribute measurably toward justifying the purchase of a Milwaukee-Matic. Inventory. The Milwaukee-Matic method greatly reduces the tie-up of your money in partly finished workpieces. With this machine, inventory may actually be reduced to a roll of tape. Quality control. Because of the precision built into Milwaukee-Matic, parts can now be produced with extreme repetitive accuracy. This reduces inspection and assembly time. Tooling costs are reduced to a fraction with the Milwaukee-Matic method. Savings in this area alone may pay for the cost of the machine in 1 to 3 years. Lead time. The conventional process of moving parts from one work center to another is time-consuming. Milwaukee-Matic manufactures parts as needed, in one place. The present policy of manufacturing to an inventory level can be changed to manufacturing to order. For years, your industry has relied upon machine tool builders to provide improved metal removal techniques. With Kearney and Trecker Milwaukee-Matic, the technique of the future is here, now. Milwaukee-Matic is bringing the benefits of tape-control automatic machining to ever-increasing areas in the metalworking industry. Through automation of job work, hundreds of companies are gaining significant advantages over their competition. The Milwaukee-Matic method of manufacturing is changing their production months into minutes.